Hello all. In this presentation, I will discuss about the implementation of MOSFET as a switch. This is the circuit diagram of implementation of MOSFET as a switch. E type of N MOSFET is used. Input is applied to the gate and source terminal, whereas source terminal is grounded. And a resistance RD having very less value, which is 330 ohm, is connected between VDD and drain terminal. VDD is taken as a 5 volt and output is taken from drain to source terminal. So we'll implement this circuit as a switch. If you observe the output characteristics of this N channel E MOSFET, then we can say that when VGS is equal to 0, no current flows through the MOSFET, and this will be considered as a cutoff state of the MOSFET, off state of the MOSFET. And in saturation region, a maximum current flows through the MOSFET, so this is considered as the on state of the MOSFET. The maximum value of VDS is equal to VDD, and the maximum value of the current ID is VDD by RDS. This is called as a DC load line, and from which we can identify the operating point also. In this presentation we discuss about the switch, that's why it is about the off state and on state of the MOSFET. If you observe the transfer characteristics are the characteristic between input voltage at x-axis and output voltage at the y-axis. So if input voltage is 0, the output voltage is maximum, which is equal to VDD, and when input voltage is maximum, output voltage is minimum. This is how we can say that MOSFET will act as a switch. Now we will simulate this circuit in the simulation software. So the circuit is built. VDD, we take VDD as a 5 volt, RD is 330 ohm. We connected ammeter in series with the drain terminal so that we can calculate the drain current, and voltmeter is connected across the drain and source terminal so that we can calculate VDS. And to observe the output, we connected the LED also at the output between drain and source terminal. So if MOSFET is considered as in cutoff region, means input is applied to the ground, no input is applied. So if input is 0 and if you simulate it, the LED will glow. And if you observe, the current is 1.776 microampere, very less current. So that's why MOSFET will act as a off state. No current flows through the MOSFET. MOSFET acts as a off state, and the voltage across this LED is equal to the cut-in voltage of this LED. It is 1.950. So when MOSFET input of MOSFET is 0, the MOSFET will act as a cutoff state and the LED will glow. So here MOSFET acts as a off switch. Now if I apply 5 volt input signal to the gate, or if I directly connect gate to the VDD, or we can say if I connect drain to gate terminal, then MOSFET will be in saturation region, and if you simulate it, LED will be off. So when MOSFET operate in saturation region, this LED will be off because the MOSFET will conduct now and it will act as a short circuit, and current always finds the low resistance path. That's why the current will be grounded through this MOSFET, and that's why we will get 0.015 ampere of current, because the MOSFET will be in saturation region and the LED will be off. That's why the output voltage across LED is nearly 0, that is 0.081 volt. So this is how we can demonstrate MOSFET as a switch in the multisim software. This is the summary of switching characteristics of N channel and P channel MOSFET. If it is a N channel MOSFET and if VGS is less than 0, then it will act as off. If it is VGS greater than 0, then it will be on. If it is P channel MOSFET, if VGS is less than 0, it will be on, and if VGS is greater than 0, it will be off. So the summary of E Mosfet as well as D Mosfet is described in this table. Thank you.